This video is going to discuss about periodic table in classification of element and size changes of element when going down the group across a period, isoelectronic species, and atom and its ion.
10 elektron. So dia punya electronic configuration kita start daripada 1s2, 2s2, 2p6. Okay, total 6, 7, 8, 9, 10. This is for element Q. So the next one I think kita boleh terus skip je sebab konsep dia sama je semua ni. Okay, so
During exam, periodic table is not provided, so we need to follow following step. Step 1, identify the proton number based on least constant. Step 2, based on the proton number, write down the electronic configuration. Step 3, identify the valence electron from the electronic configuration. We can know the group of the element based on the number of valence electron. Then we can deduce the period of the element based on the principal quantum number. And then the block, there are some pattern. If from NS1 until NS2 is block S. If from NS2, NP1 until NP6 is P block. If N-1 D1 NS2 until N-1 D10 NS2, these elements are from D block. This configuration of valence electron, this pattern is from S block.
Hi, Assalamualaikum. My name is Muhammad Haikal Ashraf bin Rafi from class F1T3. Okay, today we are going to discuss about variation in atomic radii. Okay. First of all, we need to know what is variation in atomic radii. Okay. The size or radius of atom is difficult to be defined because the electron cloud has no clear boundary. So the atomic radius is taken as half of the distance between the two nuclei of two adjacent. Okay. Not very clear, right? So kita akan fahamkan lagi lebih mendalam. Okay. Nak cari ataupun to determine the atomic radius, we can determine by two factor. First, we are using effective nuclear charge, ZEF, and second, we are using screening effect or shielding effect. Okay, the first one is by using the effective nuclear charge, ZEF. So, the effective nuclear charge ZEF is the positive charge felt by an electron. Okay, so here is the formula. ZEF is equal to Z minus S, where Z is number of proton and S is number of electron filled at the inner shell. Electron moving around the nucleus don't experience the same nucleus attraction. Electron closer to nucleus experience greater nucleus attraction. Okay. Okay, here are some example how to calculate the ZEF. Okay, now we have a chlorine. Chlorine have proton number 17, and if we calculate here and in here diagram, the number of inner shell electron is 10. So by using the ZEF formula, 17 minus 10 is equal to positive 7. So this is the effective nuclear charge. What is the conclusion? The conclusion is the atomic radii of chlorine is smaller because the nucleus pulls the outer electron closer with charge positive 7. So maksudnya kat sini, atomic radii tadi ataupun atomic radius dia kecil. Kenapa? Sebab nukleus dia menarik elektron dengan charge positive 7. Okay, masih lagi tak nampak kan? Okay, tak apa, kita next ke magnesium pula. Okay, magnesium have 1s2, 2s2, 2p6, 3s2. So how to calculate the effective nuclear charge? Same. the inner shell electron is 10. If we calculate here, the inner electron, okay, is 10. And the proton number is 12. So 12 minus 10 is equal to positive 2. Okay, the conclusion. The atomic radii is bigger because the nucleus pulls the outer electron with charge positive 2. Okay, dia cakap kat sini, atomic radius magnesium ni besar sebab nukleus dia menarik elektron yang kat luar ni sebanyak positif 2, sebanyak charge positif 2. Berbanding dengan klorin, dia punya saiz kecil kerana nukleus dia tarik dengan charge positif 7. Nukleus dia menarik elektron dengan charge positif 7. Okay, so hope you guys understand. Okay, next, determined by screening effect or shielding effect. It is caused by the mutual repulsion between the inner shell electron and the outer shell electron. It also occurs between electrons of the same shell but is less effective. Okay, right. Okay, dia macam ni lah. Contoh, this is lithium Na kalium kan. This is the nucleus. So untuk nukleus tarik the first electron, untuk nukleus tarik elektron yang dekat first orbital ni, senang ke susah? Mestilah senang kan? Okay, tapi untuk dia tarik yang second shell ni, agak-agak senang ke susah? Dia akan susah sikit. Okay, dekat natrium pula. Sorry, sodium. Terguna bahasa Melayu, maaf. Okay, here is the nucleus. Untuk dia tarik elektron yang dekat first orbital, is easy right? Tapi bila sampai dekat second orbital, nak tarik elektron dekat second orbital, it's still okay tapi susah sikit. Tapi bila sampai dekat the last orbital ataupun the outer shell, outer orbital, it is difficult because dia dihalang ataupun dia menerima shielding effect daripada orbital pertama dan orbital kedua. Okay, kita pergi kat potassium pula. Untuk tarik elektron dekat orbital yang pertama, mudah betul. Okay, untuk tarik orbital pertama mudah. Elektron orbital pertama mudah. Oh, sorry. Untuk tarik elektron pertama mudah dekat orbital pertama ni. Bila masuk dekat orbital kedua, dia agak sukar sikit. Tapi untuk narik orbital ketiga, susah dah, dah memang susah. Dan untuk tarik orbital yang paling luar sekali, the outer shell, lagilah susah. Kenapa? Sebab dia mengalami repulsion between the inner shell electron and the outer shell electron. So, ini yang dinamakan sebagai shielding effect from the screening effect. Okay. Alright. Across a period, okay, what we need to know about across a period. Okay, across a period, the number of proton is increased. Okay. So, bila number of proton increase, maka dia punya effective nuclear charge also increase. Dia punya ZEF increase. Outer electron are pulled closer to nucleus. So, bila ZEF dia increase, maka nucleus dia akan tarik dia punya elektron lebih dekat. Nucleus dia akan tarik nukleon dengan elektron dengan lebih dekat. So, di antara nukleus dan elektron punya attraction akan semakin bertambah. Okay. So, the atomic radius become smaller. Okay, size dia akan jadi kecil apabila attraction dia tinggi, apabila dia punya ZEF tinggi, apabila number of proton dia tinggi, maka dia punya atomic radius dia akan kecil. Okey, senang cerita, atomic radius akan berkurang ataupun atomic radius decrease across a period from left to right. Okay. Tutorial question 4. Explain the variation. Explain the variation in the ionic radii across period. Okay, our first point is across the period, number of proton is increased. Effective nuclear charge, ZEF, is increased. If proton number increase, effective nuclear charge also increase. And the outer electrons are pulled closer to nucleus because the attraction between nucleus and electron are stronger. So, ionic radius become smaller. Okay, that's all from me. Thank you.
Assalamualaikum dan selamat sejahtera. Hari ini saya akan menerangkan tentang isoelectronic species. So, apa itu isoelectronic species? Isoelectronic species ni bila elektron dibuang atau elektron diterima, ia akan menghasilkan electronic configuration yang sama. So,
hi everyone, today I'm going to discuss about the topic which is isoelectronic species of nitrogen, oxygen, fluorine, sodium, magnesium, aluminium and silicon. So now I will write the ions for all these elements in here. So all these ions are isoelectronic species. So later on I will prove that these ions are isoelectronic species. So firstly, we need to write down the atom's electronic configuration first. Second step is write down the ions electronic configuration. Okay. First one is nitrogen. So nitrogen has 7 proton numbers. So the electronic configuration of nitrogen is 1s2, 2s2, 2p3. So when it becomes a ions, so the electronic configuration of nitrogen 3 negative is 1s2, 2s2, 2p6. Second one is oxygen. Oxygen has 8 proton numbers, so the electronic configuration of oxygen is 1s2, 2s2, 2p4. When it becomes ions, it will have electronic configuration of 1s2, 2s2, 2p6. Third one, fluorine. Fluorine has 9 proton numbers, so the electronic configuration of fluorine is 1s2, 2s2, 2p5. When it becomes ions, it will have electronic configuration of 1s2, 2s2, 2p6. Number 4, magnesium. So magnesium has a has proton number of 12. The electronic configuration of magnesium is 1s2, 2s2, 2p6, 3s2. And then when it becomes ions, it will have electronic configuration of 1s2, 2s2, 2p6. 5. Sodium. Sodium have proton numbers of 11, so the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. When it becomes ions, it will have electronic configuration of 1s2, 2s2, 2p6. And number 6 is aluminium. Aluminium has proton number of 13. So the electronic configuration of aluminium is 1s2, 2s2, 2p6, 3s2, and 3p1. When it becomes aluminium ions, it will have electronic configuration of 1s2, 2s2, 2p6. And finally is silicon. Silicon has 14 proton numbers. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. So when it becomes a silicon 4 positive ions, it will have electronic configuration of 1s2, 2s2, 2p6. So the electronic configuration of all these ions have the same pattern, which is 1s2, 2s2, 2p6. So this shows that the nitrogen 3 negative, O2 negative, F negative, Na positive, Mg2 positive, Al3 positive, Si4 positive have the same electronic configuration of 1s2, 2s2, 2p6. Or you can write it as it has a same electronic configuration with neon. Why neon? Because neon has a proton number of 10. When you want to write the electronic configuration of neon, it is 1s2, 2s2, 2p6. So they have a same electronic configuration. So when you want to write answer, you can write with this, or you want to write 1s2, 2s2, 2p6 also can. So I will give a further explanation about the isoelectronic species about all these ions. So nitrogen 3 positive, nitrogen 3 negative, O2 negative, F negative, Na positive, Mg2 positive, Al3 positive, and silicon 4 positive are isoelectronic species because they have the same number of electrons, which is 10, and also have same electronic configuration of 1s2, 2s2, 2p6, or the same electronic configuration with neon. Okay. The proton numbers will increases from nitrogen 3 negative to silicon 4 positive. So the effective nucleus charge will also increases from nitrogen 3 negative to silicon 4 positive. This is because the nuclear charge or the proton numbers inside the ions will increases, but the inner electrons will remain constant. So it will cause the stronger attraction between the valence electrons and also the nucleus. That's all from me. Thank you.
Hello everyone. So today I would like to talk about isoelectronic species and the variation in ionic radii across period 2 and period 3. So from this graph, we can see that across period 2, the ionic radius decreases, and in the middle it suddenly increases, and then it continues to decrease. So to explain this, across period 2, the ionic radii will decrease from lithium plus to boron 3 plus. The ionic radii will decrease from nitrogen 3 minus to fluorine minus, but the ionic radii will increase from boron 3 plus to nitrogen 3 minus. So this is because across period 2, there are actually two sets of isoelectronic species. The first set consists of lithium plus ion, beryllium 2 plus ion, and boron 3 plus ion. These ions are isoelectronic because they share the same electronic configuration of 1s2. So when moving across the period, the proton number will increase and the effective nuclear charge will increase. Thus, the electrons are put closer towards the nucleus and the ionic radius will decrease. So for set B, nitrogen 3 minus, oxygen 2 minus, and fluorine minus all have the same electronic configuration of 1s2, 2s2, and 2p6. So when moving across the period, proton number increase, effective nuclear charge increase, electrons closer to the nucleus, ionic radius decrease. So how do we explain the sudden increase from B3 plus to N3 minus? Well, by comparing their electronic configuration, we can see that the N3 minus ion has an additional electron shell 2s2 to p6. Thus, the screening effect increases, so the ionic radius will increase. The same thing occurs when we look at period 3. From period 3, the ionic radius will decrease from sodium plus to silicon 4 plus. The ionic radius will decrease from phosphorus 3 minus to chlorine minus, but the ionic radius increases from silicon 4 plus to phosphorus 3 minus. The explanation is the same. There are two sets of isoelectronic species in period 3. The first set consists of sodium plus ion, magnesium 2 plus ion, aluminium 3 plus ion, and silicon 4 plus ion. All four of these ions have the same electronic configuration, 1s2, 2s2, 2p6. So moving across the period, proton number increases, effective nuclear charge increases, electrons closer to nucleus, ionic radii decreases. The second set is phosphorus 3 minus, sulfur 2 minus, and chlorine minus. All three of these ions have the same electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6. The explanation is the same, proton number increase, effective nuclear charge increase, electrons are put closer towards the nucleus, and the ionic radius will decrease. So the explanation of the change from silicon 4 plus to phosphorus 3 minus is the same. By comparing these two ions, we can see that the phosphorus 3 minus ion has an extra electron shell, 3s2, 3p6. So phosphorus 3 minus ion has additional electron shell, screening effect will increase, and the ionic radius will increase. That's all. Thank you.
Hi everyone, so let's discuss about chemistry chapter 3, which is let's discuss about negative ion or anions. Negative ion always larger than their neutral atom. Because of why? Kita ambil contoh chlorine atom. Chlorine atom ada 17 elektron and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. And then when Cl atom bertukar menjadi Cl ion, Cl minus, it tends to gain 1 electron. And then the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. The Cl atom, the electron valence is 7. The Cl ions, the electron valence is 8 because it gained 1 electron. When electrons are added to an atom, repulsion between electrons will increase, cause it to spread out and experience less attraction from the nucleus. Semakin besar size, so semakin kuranglah attraction between nucleus and electron valence. Hence, electron cloud enlarge. So, anion is larger than its atom. So, ini contoh untuk negative ion. Bila elektron makin bertambah, the size become bigger. When more electron is added, so the repulsion between electron is increased. Okay, let's move to positive ion. Positive ion smaller than the neutral atom. Because of why? Okay, kita ambil contoh Na. Na natrium ada 11 elektron and then the electronic configuration is 1s2, 2s2, 2p6, 3s2. When Na become a Na plus, it tend to remove 1 electron and the electronic configuration for Na plus is 1s2, 2s2, 2p6. The 3s1 at the Na plus is removed because of remove 1 electron. When electrons are removed from an atom, repulsion between electrons decrease. Number of protons remain, nuclear charge remain the same. Remaining electrons are pulled closer toward the nucleus. Hence, electron cloud shrink. Cation is smaller than its atom. Okay, so ni contoh untuk positive ion. When electron is removed and then the size is become smaller. So the repulsion between electron is decreased. Thank you. Hope you enjoy.